So, yeah, here's my presentation. Is it visible?
Yes.
Yes, cool. So let's start. So today we will discuss bathymetry and bathymetry in common and different technologies which are used for bathymetry, including all the tools and technologies which are available on the market, typical applications for bathymetric systems, and what is bathymetric bundle from SPH Engineering, differences between models of Echer sounders, between single frequency, between dual frequency Echer sounders. We will briefly touch data processing, and I will try to answer your questions. And my colleagues will also help me to answer your questions. So let's start. What is the bathymetry? Very simple. Bathymetry is the measurement of the depth of water in different water bodies. It can be ponds, lakes, oceans, rivers, anything, or even pools. Results of bathymetry can be presented in different forms. For example, here is cross-section of bottom elevation. Actually, it is not the depth, it is elevation of the bottom. Here on the right, different representation of the result of survey. It is colored depth map and isolines of the equal depth. Also, it is not in my presentation, but I can show here. Results can be presented even as point cloud. Here you can see on my screen combined point cloud collected using LiDAR mounted on the drone, and also results of bathymetry here. Little bit of history. Water depth measurement as a problem, as a task, exists for the thousands of years. As soon as our civilization started to build something in the water, I mean piers or bridges or something, and also when we started navigation in the water. First methods were very simple. It was measurement poles, for example, or some weight on the rope. But 100 years ago, approximately in 1920s, it was started production of first devices, which were first Echer sounders, actually. They were marketed under the name of photometer. Principle was absolutely the same as in current Echer sounders. It was the kind of loudspeaker which emits sound impulse here and microphone, and some device to measure the time difference between moment when we sent the impulse and when we received the echo. Principle stays the same for modern devices, but modern devices actually, of course, are much more smaller, much more lighter, and they use digital processing technology to measure the time. But principle is absolutely the same. Echer sounder will send the impulse to the direction of the bottom, will analyze reflected sound, reflected signal, and when we see the peak of the reflected sound, device will think that it is reflection from the bottom. As sound speed in the water is pretty known, it is approximately 15 hundredths of meters per second. we measuring the time, we can recalculate the depth using that formula. Very simple. What current technologies are on the market at the moment to do bathymetry, to measure the depth? Old method using measurement pole is still used, of course. It can be a bit more modern. It is not just a measurement pole, but it can be stick with RTK or PPK GNSS receiver on top of stick. Second method, it is single beam Echer Sounder. It is what we propose on the market. It is a device which emits single beam Echer Sounder. More sophisticated device or technology called multi-beam Echer Sounder. Demonstration of the concept is here. It simulates actually multiple beams perpendicular to the direction of survey line. Benefit is great actually. In the single pass, multi-beam Echer Sounder can measure the depth in the some quite wide lane, demonstrating the huge improvement in the bathymetric coverage or density of measurements on the bottom, and also minimizing the number of lines necessary to cover the bottom. Next, very modern, quite modern and very good technology is called green LiDAR or bathymetric LiDAR. Why is green? Because green light has the better penetration through the water. Benefit of that technology is that in the single pass, you can get point cloud from the surfaces which are under the water and also from everything which is not in the water. It is extremely useful when you collect data, for example, for the construction works, and you need to collect the data from both parts of surfaces, under the water and on shore. Also, there is satellite-derived bathymetry, but I mentioned it is just to mention it actually. In theory, it is great because it provides the data for huge areas, but resolution of that method is not enough even for navigation, and it is not enough for the most scenarios when it is necessary to collect depth data, bathymetric data. Why we supply at the moment only single beam Echer Sounders? First of all, why we don't supply multi-beam Echer Sounders actually? Because currently available multi-beam Echer Sounders usually are quite big and heavy. We are targeting more or less mass market, meaning that system should be suitable for medium drones like DJI 300 and 350 or similar drones. That's the main showstopper. And multi-beam Echer Sounders will require almost the same additional components as sliders. They will require inertial measurement unit, and they will to precisely position every point of measurement in the space. We will need to know course or direction of the device for every measurement. It is quite not a very simple task to achieve that using something attached to the drone. Green LiDAR technology is absolutely great, but there are at least a couple of showstoppers which prevent widespread or wide adoption of that technology. First of all, bathymetric LiDARs have very limited penetration or very limited maximum depth. Technically, they will not work in most of inland waters like rivers, ponds, lakes. They are very good actually only for coastal areas when water is more or less transparent. Second showstopper at the moment is quite high price of the devices. So 100 of thousands of euros, it's a, or even more, it's a normal price for such devices. Quite typical question what we receive is about side scanning sonars for bathymetry. Here I should explain that side scanning sonars are very similar to multi-beam echo sounders. They use the same technology, but they are not bathymetric tools. They are not designed to measure the depth. I can show you results of the search, some pictures from internet. It is what you can get from side scanning sonars. They generate kind of pictures, synthetic pictures of everything what is on the bottom. Very exciting result, but they are mostly search and inspection tools. Using side scanning sonars, you cannot measure the depth with high precision, which is usually necessary for bathymetric surveys. So, next. Technically, echo sounder in every application will measure the same, but there are many quite typical application scenarios for echo sounders. First of all, it's a dredging planning monitoring. Before dredging, you need to estimate, or your customer, need to estimate amount of work. And during the process, you need to monitor what was done actually, because the contractor for the dredging will bill the customer for the amount of removed sludge, sand, or something from the bottom. Next typical scenario is construction planning, when you need to build something crossing water, piers, bridges, anything. The next scenario is related mostly to the mining industry, tailing storage facilities and open pit lakes monitoring. First of all, to measure or to estimate volume of water and a maximum capacity of storage facilities or open pit lake. Very interesting scenario is a bathymetry of some lakes or pools with aggressive liquids. Most interesting scenario what I saw was the bathymetry of open air storage with dissolved acidic solution. Bathymetry using drone, in many such cases, it's the only possible scenario, because you cannot use old-fashioned way, I mean, guy with a measurement pole, and also remotely operated vehicles or automatic boats, robot boats, may not have enough lifetime in such liquids. Very popular scenario related to the different environmental tasks. It's bathymetry, sediments monitoring, monitoring of seaweeds for different purposes, scientific, ecological surveys, everything. Very interesting scenario. It's a new scenario for us. It's collecting of bathymetric data together with data from using many additional sensors like surface velocity sensors and LiDAR to collect profiles of the parts of rivers which are not under the water at the moment, to calculate maximum discharge of the river. And ultimate target is to predict floods and post-floods mapping. That scenarios are pretty common in what we see from our customers. You will receive the copy of that presentation, and here are links where you can find some additional information, and actually all that links are about case studies or some stories from our customers. Few words about components of the system. So Echer Sounder is just of one of few components. It is here on picture. We use heavy housing for Echer Sounder to keep it almost vertical in the water when drone is dragging Echer Sounder. Echer Sounder is attached to the drone using cable. Cable is protected. And next component is onboard computer. It is small brick on the leg on drone here. Onboard computer acts as a data logger from Echer Sounder, because Echer Sounder is a just sensor. It sends measurement through wire to the onboard computer. On board of SkyHub, it is name of our onboard computer, we store bathymetric data actually in three types of files. CSV, NMEA, which is industrial standard for bathymetric data, and SIGWAI files, if it is necessary, to log full wave data coming from Echer Sounder. Also, SkyHub keeps the constant altitude of the drone over water surface, which is very important for measurement precision and also actually for the safety. Onboard computer uses altimeter installed on the drone. It is here. It can be laser or radar altimeter to measure actual real-time distance from the drone till water surface to keep the altitude more or less constant. Flights or bathymetric missions, survey grids are planned in UgCS. It's our flight planning software. And flight also monitoring in UgCS. And last, and also very extremely important component of the tool chains is data processing software. We recommend HydroMagic. Here is the picture of the system with DJI M300 or M350 drone. I don't remember, looks like M300. But the system is compatible with M300, M350, and M600, and it can be used with drones with Pixrock Autopilot. I can mention the few drones which are tested with bathymetric system. With our bathymetric system, it is Inspired Flight IF-12 100A, Harris Aerial Drone, and Whisper Ranger Pro. But in theory, it can be used with any drone with Pixhawk autopilot and Ardocopter firmware. Why Ardocopter? Because Ardocopter has native implementation of terrain following with external altimeter, which is very important for bathymetric surveys. Why it is beneficial in some situations to use Echer sounders attached to the drone? Because, of course, there are multiple methods to do the same job. I can mention guys with measurement poles, manned or unmanned boats, or remotely operated vehicles, or automatic boats. First of all, if you use Echer sounder with drone, you don't need entry point to the water. We saw the cases when survey area was in, as I remember, 400 or 450 meters from takeoff position. It is especially important when you don't have physically possibility to be close to the water, or access to the water is limited for some safety reasons. Safety most of all. For example, if liquid in a pond or lake is aggressive and dangerous. Second reason, combination of drone with Echer sounder maybe is the most portable system for bathymetry. It has very low time necessary for deployment, for transportation, and for demobilization. Very interesting that if we will compare the bill from contractor for bathymetric survey from company who do surveys using, for example, multi-beam surveys using manned boats, and the same from contractor which will use UAV or drone with single beam Echer sounder. Multi-beam system, which will have maybe 10 times better productivity in terms of the square meters or hectares or square miles per hour or per day of the work. But in reality, base for the manned boat may be in dozens or hundreds of kilometers from your survey area. But contractor will bill you for all the time when bathymetric boat, hydrographic boat will leave the harbor and will return back. In many cases, bill or cost for the same amount of work using the UAV with Echer sounder will be much more less comparing with the system which in theory has much better productivity. Next benefit is possibility to work in not safe or not safe environment. I already mentioned it. And last maybe benefit is extremely high precision of the drones when they follow survey lines. Drones in RTK mode can follow survey lines with precision plus minus 10-20 centimeters, and that precision is not possible when you use manned or unmanned boats. We by default we propose the packages with 3 types of Echer sounders. All Echer sounders are manufactured by Korean company called Ecologer. It is absolutely standard Echer sounders, no any modifications for the drones. The same Echer sounders are used on manned and unmanned boats. Why we have three types of devices. Single frequency for high frequency with pretty high frequency for 150 Hertz, dual frequency with 200 and 250 kilohertz, and last model, dual frequency device with 50 and 200 kilohertz. Because the Echer sounders will have different possible applications. I will explain the difference on next slides, but here I want to stress very important parameter of the devices, a measurement range. Actually, maximum measurement depth is not very important because we don't position our systems for the surveys in open seas or oceans. And honestly, maximum depth, what I saw, maximum measured depth, what I saw from our customers was around 50-60 meters. But minimum possible depth is very important because most of the scenarios, most of the applications of our customers are pretty shallow waters. So if you need to measure the depth less than 1 meter, you cannot use that device because minimum depth will be for lower frequency will be 1 meter. Maybe you can use that model. But in many cases, when your water body is very shallow, say half of meters, you can use only single frequency Echer sounder because of deep zone. That's the measurement range for the device, and to get a practical minimum depth, you need to add at least 10-15 centimeters because Echer sounder during the measurements should be submerged to the water. All Echer sounder models have integrated tilt sensor. It is very important because it allows us to, in software, to check if the sensor was vertical or almost vertical during the measurements and reject all measurements when angle of the sensor was outside of some set threshold. And also, Echer sounders, all models have temperature sensor. For what it can be useful, you can better estimate water speed, sound speed in the water, because it depends on the water temperature. So by default, our software and Hydromagic will use 1500 meters per second as a sound speed, but you can, if you know the temperature of water, you can make corrections for the waters for the sound speed. And of course, if you want to achieve max possible precision in terms of sound speed, you can use separate devices called sound velocity profilers. But it is actually if you need to achieve extremely high precision. Normally, temperature of the water measured by a built-in sensor will be enough. And weight of all types of devices, all types of packages, what we provide is optimized, honestly, for DJI drones, 2.7 kilograms. It's a maximum rated payload weight for DJI 300. But that means that any drone which can carry 2.5 or 2.7 kilograms can be used with our system. As I promised, difference between Echer sounders or for what Echer sounders can be used. First model, single frequency echo sounder with sound frequency 450 kilohertz, will measure the distance till the first sound reflector. It can be top surface of sediments or dense seaweeds, or actually not the sharks, but sometimes in the data we see the short spikes from the fishes. High frequency sound will be reflected from first obstacle for the sound or first reflector. That means that if bottom is covered with dense vegetation, a lot of seaweeds, you will get a data with a lot of spikes, which should be removed manually during post-processing if you need to get the depth till the bottom. But as I mentioned, that model of echo sounder has shortest dead zone, around 15 centimeters, and that's the only model which can be used to do bathymetry in very shallow water bodies. Next model, Echer DD24. It's a dual frequency device, and it has two frequencies. What is the dual frequency echo sounder? Technically, it is two echo sounders with two acoustic frequencies combined in the single casing. They will sequentially emit the sound impulses with different frequencies, higher frequency, lower frequency, and measure the depth for every frequency. What's the benefit of that approach? High frequency sound, the same as for previous model, for 450 kilohertz, will give you measurements till first obstacle, first reflector. It can be top of bottom, or it can be seaweeds, anything on the bottom or in the water. But 200 kilohertz sound with the frequency 200 kilohertz in most cases will penetrate through vegetation on the bottom, and you will get a quite clean picture, quite clean image of bottom in your data. I can show you how it looks. Yeah, it is here. It is cross-section of the lake collected using that model of echo sounder. Green line is for low frequency. Red line is for high frequency. So high frequency data is pretty noisy, has a lot of spikes. It is reflection from the seaweeds, from vegetation. And last model, dual frequency echo sounder, model called Echer DD052, has frequencies 50 kilohertz and 200 kilohertz. 200 kilohertz is the same as in previous model, lowest frequency of previous model. It will penetrate through all vegetation, all small reflectors on the bottom, and will measure the distance till the top surface of the bottom. And in case of organic or light sediments, lower sound with lower frequency will penetrate through hard bottom. Honestly, it is not guaranteed. It depends on the volume or thickness of sediments. But in case if layer of light sediments, something around few dozens of centimeters maximum. In the data, you will see two horizons, reflection from the top of the sediments and a reflection from bottom of from hard bottom. So in the single pass, in theory, you can get two measurements till sediments and till hard bottom, and can estimate the volume of sediments. Why it is not guaranteed? First of all, it can be too thick layer of sediments, and it will suppress even low frequency sound. Second, that works for 50 kilohertz, that works with mostly with organic and light sediments. If sediments kind of clayed mix of sand or clay or something over the hard bottom, 50 kilohertz will not penetrate through such mix, such heavy mix. In such situations, if you need to measure the thickness of the hard sediments, of heavy sediments, you need to use devices with much lower frequencies or even hard bottom, sub-bottom profilers. But such devices are will be too heavy to use them with medium drones like M300 or similar. I hope it is clear. For me, most universal device is that one, because it will allow to collect clean data in most situations. But yeah, if you need to profile also sediments thickness, better device is that one, but you need to take in account quite large dead zone for lower frequency. For 50 kilohertz, it will be 1 meter. So you cannot collect data using that Echer Sounder for 50 kilohertz in very shallow ponds or rivers. Standard question actually for the dredging monitoring, for the sediments build-up monitoring, how we can do, how we can estimate sediments amount if sediments are not organic, if sediments are heavy, or pond or lake is actually pond is very shallow. The only method is to compare the data collected using high frequency model or Z model with the data as built or data collected right after the dredging. That's the only way. Of course, that works only comparing with the as-built model or as-built documentation work only for with the artificial water bodies like technological ponds or tailing storage facilities. Comparing with the data collected after the dredging, of course, depends on the possibility to collect such data, and you can use that approach only after some time. So, let's touch a bit data processing. What we will get as a result of bathymetric survey, we will get some files, and you need some software to process the data, to generate some standard output materials like colored depth maps or expert point clouds or to cross sections. We recommend Hydromagic. Why we recommend it? Because we test all releases of our software with Hydromagic for compatibility. But in theory, you can use any software which can import CSV files or which can import NMEA files or SIGY files. But HydroMagic is tested, and we can guarantee that HydroMagic is fully compatible with all our software. We support direct import without any additional data transformation in HydroMagic, and HydroMagic can be used to export all standard output materials or reports which are necessary to end users or to customers who ordered bathymetric surveys. It can be DXF files or KML or GIF files or even point clouds. The standard question about the system: how accurate, how precise are results? Precision is absolutely the same as in case of manned or unmanned boats, because we use the same core technologies. We use the same survey grade Echer Sounders, which are used on manned or unmanned boats. We use RTK receivers on the drones, which have very high precision currently. We used the same processing workflow or processing chain. So results, if user of the system do everything in the right way, results will be absolutely the same. In past, when we just introduced the system to the market, it was in 2020, as I remember. Many of our customers did comparison of data in terms of accuracy, collected using our system and collected using some more traditional way. So here is a snapshot of the data collected by one of our very first customers for the bathymetric system, a company called GeoPartner from Denmark. Numbers in red circles are measured using pole with Trimble RTK receiver. And we can consider that numbers as very precise. Sequence of Z numbers are collected using our system. And you can see that data is almost the same. Results are almost the same. So distance between measurement points, I mean between manual measurements and track of data from the drone, is approximately half of meter here. But actually, we don't know what results are more precise, because it was in North Sea, as I remember, in February. It was not the very comfortable job for the guy with measurement pole. And but anyway, that company and a few other our other customers did similar comparisons, and we can see that accuracy of the system is absolutely the same as with any bathymetric system which utilizes the survey grade Echer Sounders and RTK receivers. Some tips to achieve high quality results with very high accuracy. First is we recommend to follow the standard recommendations and to have check line for every bathymetric survey. What is the check line? I can show you in that project. check line, it's a line of measurements which will cross your planned survey lines. So here in that survey, actually it's a data collected close to our office. It's a kind of our house lake where we test our systems. So here are four survey lines and 4 check lines. When lines are crossing, we can compare the results, and ideally, they should be the same. Here numbers are elevation, calculated elevation of the bottom. We can compare the data measurements visually using our eyes, but Hydromagic processing software has special function to do the job in more accurate and systematic way. You can place over your survey lines sections, cross sections, lines which define a direction of survey lines and cross sections. And after that, use function called cross section statistics to calculate difference between measurements. Here are few methods or few channels to calculate difference. For dual frequency echo sounders, we recommend to compare the elevation calculated for low frequency. Why elevation, not the depth? Because depth interesting, but depth is less precise in terms of measurements or in terms of results generated by all bathymetric systems. Calculated elevation will be more precise. And actually, if we do bathymetric surveys in some rivers and lakes, elevation of the water surface can be different in different amount of times because of tides, because of actually variable amount of water in pond, for example. Better to compare the data for elevation. Why for low frequency? Because if we will compare the data for high frequency, we can compare the data for that spikes. But we need to compare the accuracy of the system for the bottom. So we need to select here our bathymetric data and cross sections and calculate. And we will see difference. For every point, I don't show it that you can see small red circle here. But for every point, currently it is here, we can see the difference between survey lines and between check line. Here it is just 4 centimeters, 4.5 centimeters. And also software will calculate the deviation and so on. It is very good result because here is elevation, but if we will compare the depth, actually it is again. One second, guys. Yeah. So difference was around 4 centimeters, for the depth more than 7 meters. That means that difference is less than 1%. And it is pretty in line with all most strict requirements for accuracy of bathymetric surveys. Next recommendation is to follow our recommended speed. For drugged Echer sounder, we limit recommended speed by 70-80 centimeters per second. It is because the fact that water drag is proportional to the second power of the speed of object in water. That's the main limiting factor of our system, actually. Quite limited speed on survey lines. And if you follow that recommendation, you will get very precise results. In some cases, when it is acceptable to have not very accurate data, if you need just depth estimates, you can use higher speed, but results may be not in line with high requirements for the accuracy. I should say that we are working on the next generation of the system. We are doing modeling of the different shapes of Echer sounder housing to increase survey speed. Our plan is to provide kind of add-on for the existing systems. And we expect that we will increase the survey speed at least twice. But recommendation for the current system is 70-80 centimeters per second as a maximum speed. You can also in hydromagic, you can apply different corrections for the collected data. As we collect angles of Echer sounder, we can recalculate actual depth according to the angles of Echer sounder in the water. But that function should be used with high caution, because in case of very rough bottom terrain, it can give you not actually what you want. So I personally prefer to avoid such corrections. But in case of quite smooth bottom, that correction can be used. And also, I mentioned it before, you can use additional devices called sound velocity profiler to measure the sound speed for the different depth levels. It can be very useful, for example, if you have thermocline in the water with very different temperature of the water on different levels. And also you can use some additional methods of data corrections to increase the accuracy or precision of measurements. So here is the link to the paper dedicated to questions of accuracy and precision. So we have just 5, maybe 10 minutes for the questions. Uh, 23 questions, actually. So, question from Gatis. Do you compensate for dragging effect on single beam Echer sounder transducer, like positioning difference between drone and transducer itself and inclination angle of transducer? So for inclination angle, I already mentioned that we can make corrections for the angle during post-processing. And our software also rejects the measurements when angle is outside of set threshold. You can set that maximum angle in the settings of the system. We don't do position corrections for in horizontal plane, because if survey speed is 70-80 centimeters per second, Echer Sounder position will be approximately 30 centimeters behind the drone. So if you want, you can account that lag during post-processing, but in all cases, what I know actually, it is not necessary because, for example, if we will read the requirements for the positioning in International Hydrographic Organization standards, as I remember, most strict requirements are 3 meters. So for a drone with RTK receiver, for the 30 centimeters behind the drone, you will be pretty inside of such most strict requirements. But if you want, you can make such corrections during post-processing. Next question. Next question, actually the same, more or less the same, about precise position of submerged Echer Sounder in the housing. Actually, I already answered. So, okay, as that question is popular, guys, you can, if you use survey lines in quite quiet wind, position of Echer Sounder behind the drone will be more or less constant. Of course, excluding the situation when you do surveys in the river and you are doing not cross sections, not perpendicular to the direction of the current. So such lag you can account, but we are experimenting with DJI M350. Finally, DJI opened the access to the built-in cameras of the drone. We are experimenting with visual tracking of the Echer Sounder in the water because you saw that on top of housing here, we have orange cap, plastic orange cap, and it is visible even in not transparent water, usually quite well from the drone. So we are working on visual tracking, but actually it is kind of very on top of tart. It is not necessary to have better positioning in most cases. Next question. Great question from Christopher about surveys in river. So recommended survey speed is 70-80 centimeters per second, but it is not absolute speed. It is recommended speed relative to the water. So standard problem. Water flow speed is high, more than 70 centimeters in the water, and you need to collect the data for cross sections. Typical task for bathymetry in rivers. What we recommend? We recommend to use zigzag road across the river, not straight cross sections, but zigzag. On the half of segments of that zigzag, you will get good data because you can adjust the speed of the drone to have a speed relative to the water inside of recommended range. On the opposite segments, data will be automatically rejected because most probably angle of Echer Sounder in the water will be outside of set maximum angle. So we have an example of data collected in the rivers with extremely high current, around 2 meters per second. So that's possible. Next question from Pierre. How about the fall operating? Sorry, guys, I don't understand the question. Please clarify it. If the question related to the risk to lose your drone in the water, answer is very simple. In my company, it is prohibited to fly over water without insurance. But in our practice, we did hundreds of surveys, test surveys, real surveys over the water, and we still have all our drones with us. So we supplied more than 100 systems to our customers. I know about 2 cases when drones were lost in the water. First case was when customer tested the system for maximum possible speed, and they catched something in the water at the speed, as I remember, around 4 meters per second. First of all, it was absolutely crazy attempt. And it was absolutely useless because Echer Sounder was not submerged in the water, actually. Reason of why second case happened, we don't know, because drone was recovered from the water approximately after one year. And we cannot extract the log files. But ultimate answer to that problem, to that risk, is insurance. Next question about do we support ECT D052 model with a lower frequency? It can be used. It is supported in software, but you need to use larger drone, like DJI 600 or Inspired Flight 1200. Yes, you can use the models with the lower frequency. If you will order this full system from us, actually you will pay a couple of hundreds of euros more comparing with the standard packages, just for more stainless steel in Echer Sounder housing, more heavy, more bigger Echer Sounder housing. What about the rivers with rapid flow or waterfalls? I already answered about how you can do surveys in case of high speed of the water. You can use zigzag roads. How the tidal, next question from Christian, if I pronounce right, how the tidal corrections will be applied, especially at open sea area. So if you use drone equipped with RTK or PPK receiver, you don't need to apply tidal corrections. If you cannot use PPK or RTK, if you will measure the depth relative to the water surface, you need to apply tidal correction. So somehow you need to measure the water surface level, and HydroMagic can import file with tidal information. How much is one swash width of scan? So for single beam Echer Sounder, it's just 1 point. Of course, you can check the height of the beam, but better to interpret the single beam Echer Sounder as a kind of altimeter, because in case of rough terrain, you cannot estimate precisely from what point of footprint of beam you measured the depth. Next question from Jared. What happens if the Echer Sounder snags on something is the release, quick release device or safety release device on the drone. We don't have such device. One of our partners from UK can supply such device, but again, ultimate solution is insurance. But in practice, if Echer Sounder will catch something not very hard, like seaweeds or wires or a fishing net in the water, operator will still have at least couple of seconds to react. Also, our system, terrain following system, which is used for to keep constant altitude over the surface. In the settings, you will set minimum and maximum altitude for altimeter, for radar or laser altimeter. Normal altitude for the flight will be approximately 1.5 meters. You will set, if you will set, say, something like 1 meter, if drone will be catched by something, in attempt to continue the survey lines, drone will lose altitude, and when it will reach 1 meter, drone will stop automatically and will try to climb up. It will give operator additional seconds to react. But again, form of the cup, plastic cup, on the Echer Sounder is chosen to make it easier task to extract the Echer Sounder assembly from the water. But again, third time, one more time, better to have insurance. Question from Agnes. Which Echer Sounder do you normally use, and does it give great results? We use Echer Sounders from Korean company called Echologger. It is survey grade devices, and they provide very good results. Next question is about drone battery consumption when a drone is dragging Echer Sounder. So great question. Or how much kilometers or meters we can cover per single set of batteries? For M300 or M350, I personally prefer to be very conservative in the terms of the how many percentage of battery level I can have before I will interrupt the flight and return a drone back to the shore or to the pier to change the batteries. I prefer to have at least 30% of batteries. Usually time on survey lines when a Echer Sounder is dragged in the water will be around 25 minutes for DJI M300 or M350. What size of water body is best suited to the technologies for the drone? So usually best case scenario for Echer Sounder on the water, on the drone, if we consider fact that speed on survey lines is limited and you will need to change batteries every maybe 25 minutes. Sorry, I cannot recalculate acres to the European units. It's a few hectares. It's an ideal size. It is what you can cover in few flights. But as I mentioned, in some cases, in terms of cost of the project or price of the project. Echer Sounder on the drone can win comparing with the manned boat because of much less mobilization costs. Please, next question is, please explain, or can I see the illustration when using grasshopper mode? Later, I can send you examples for grasshopper mode. I mean data examples. Grasshopper mode is used in two cases. First of all, you have a lot of different stuff in the water, a lot of seaweeds, wires, cables, something, and risk to catch something using Echer Sounder when it is dragged in the water is very high. Second, you want to cover very large area, and your customer or you is okay with not very high density of measurements. So it is planned in UgCS as a sequence in waypoints. Yes, and we support automatic grasshopper mode. You set how many times drone should keep lower altitude when Echer Sounder is in the water, and measurements are fully automatic. So question about accuracy, comparison between the data accuracy from the drone Echer Sounder and regular boat USV Echer Sounder. Actually, I already discussed that there is no drone Echer Sounder or boat Echer Sounder. We use the same type of Echer Sounders and the same type of positioning technologies, GNSS, RTK, or PPK receiver. So accuracy is absolutely the same, absolutely the same. Question from Jared: in what CRS is data collected? Coordinate system. We collect the data in terms of latitude, longitude, UgCS 84 coordinates, and ellipsoidal elevation. In HydroMagic, you can use any projection. And also in HydroMagic, you can load geoidal model and produce output result in datum what you need. Question from James Frank, what software did you use to stack the bathymetric data with the surface slider in a single figure, or in how to join data sets? HydroMagic allows to export LiDAR data. Actually, file export, kernel, not here. So here you can export point cloud. So you can use any software which can import, process, visualize point clouds to join data from Echer Sounder and from the LiDAR, from the drone or from manned aircraft or terrestrial LiDAR data. It's not a rocket science at all. It's just a few clicks of mouse. Next question. Question from Mark. we have tested an Echer Sounder from a drone and compared it to our multi-beam Echer Sounder data, and have found that since there is not a GNSS on the Echer Sounder itself, and it was utilizing the corrections from the drone, since the cable holding the Echer Sounder is not rigid, it could be affected by water current and drone movements. We already discussed that. So in normal conditions, if data was collected following our recommendations, positioning error or displacement of Echer Sounder will be around 30 centimeters. It is pretty inside of all possible requirements. So again, a question about the width of the scan. It is single beam. Question from Daniel: should the dead zone be added when calculated water body depth data? It is calculated automatically. So dead zone, it is dead zone 15 centimeters means that inside of 15 centimeters, you will not get any measurements. Starting from 15 plus few millimeters, you will get 15 centimeters plus few millimeters. So you don't need to do any additional operations to process the data. Question: what is the estimated flight time for M250? What is the M250? Maybe M210, M300, M350. We had in past couple of customers who used M310, but I don't remember flight time. I can check for M300 and M350. Normally it is 20-25 minutes when Echer Sounder is dragged in the water till 30% of the battery. In order to get, next question, in order to get the comparison of the data accuracy, is this function only applicable if we use dual frequency Echer Sounder? No. You can use cross-section statistics for high frequency, for single frequency Echer Sounders as well, but you need to understand what you will compare. Actually, even for high frequency, if you manually will clean the all spikes, you can get reasonable comparison of in cross sections. Next question: for existing users, can a 3D printed shape be made available to reduce drag? So actually, we are working on such a DOM, which will be a kind of additional fin or something, and it will be available for existing customers. What is the typical system price? Please, my sales managers will answer on that answer, but you can find the prices and typical packages on our site. Excellent question from Prosper. Have there been a solution to PPK processing with regards to the usage of M300 drone? Answer is no. Without additional equipment. Unfortunately, M300 and M350 drones support PPK mode, but only if you use DJI payloads like L1, P1, DJI cameras or DJI lidars. Only in that case, you can fly in PPK mode and have a kind of Linux file logged on the in the memory card of your payload. In theory, you can fly with DJI camera or DJI LiDAR together with Echo Sounder just to have Linux file logged during the flight. As a possible solution, you can use absolutely any PPK or PPK receiver, additional receiver on your drone. We, in our practice, use MLEAD M2 model receiver mounted on top of the drone just to log PPK data. And HydroMagic allows to use logs collected for PPK from PPK receiver to inject precise coordinates and elevation into the bathymetric data. It's a standard function of HydroMagic. Again, flight time of M300 with Dragit Echo Sounder 20-25 minutes. Next question. Good question. From Majid, sorry for my pronunciation. How you keep the probe depth constant during the survey if there are waves? So, drone is equipped with terrain following mode, and when drone is flying above the water, the system actually keeps more or less constant elevation of the drone above the water surface. In case of waves, drone will try to keep the constant elevation over the water surface. And if waves are quite smooth, drone will fly with the waves up and down. That means that your depth measurements, so imagine the absolutely flat depth, bottom. You will get some sinusoidal plot of the bottom depth in your data. It is why you need to fly in RTK mode or with PPK receiver, because you will, for every moment of time, you will have elevation of the drone in the space, and you can calculate very precisely elevation of the bottom. Actually, absolutely the same with manned or unmanned bot, because they will go with the waves up and down. Absolutely the same. Yeah, and you don't need, if you will fly in RTK mode or with PPK receiver, you don't need to do any additional steps to account waves. Everything will be done just automatically. Next. Actually, due to the recommended speed, how long does drone battery can improve the maximum length bathymetric measurements? Actually, as I understand, the question is the same. Currently, with the recommended speed for DJI drones, it can fly for M300, M350. It can fly around 25 minutes till 30% of the battery level. With new planet modification, maybe you can fly longer or with higher speed. Can you explain the possibility of the bathymetric river performance for off-road vehicle river crossing? Can you, so question from Marian, can you explain the possibilities of the bathymetric river profile measurement for off-road vehicle river crossing? So it's just collecting the data for cross-section. I don't see any special problems here, or maybe I didn't get the problem. So you can answer, you can ask, you can send more details later. What is question from Zilvinas? What is the cases, conditions when you are not able to use the solution? Extremely high current, for example. When you cannot, when the current speed is so high, or along the cross section, current speed is not more or less the same, so you will not be able to use our system because Echer Sounder will not be stable in the water. One more scenario when water is covered with ice, for example, because Echer Sounder should be submerged to the water. For such cases, we can recommend low-frequency GPR system. We also supply such systems. They work not bad in the fresh water with low if water has low electrical conductivity. But in most cases, you can use Echer Sounder attached to the drone. It is actually benefit of the technology. It is very robust. If you able to put Echer Sounder to the water and it will be more or less vertical, you will get measurements. How is approximate the cost of line 1 kilometer? Guys, if you will calculate the cost of kilometer, for most cases, for our system, most cost will be in logistic expenses. So imagine that you need to survey some pond. It has the surface, say, a couple of hectares, but you need to drive a couple of hours. So most of your cost will be in logistics. It should be calculated for particular project. Next question is, what about the radar viewer profile measurement comparing the bathymetric measurement? I don't understand the question. You can use radar to measure the water level, but not to collect bathymetric data. Or if you mean low frequency ground penetrating radar, I have data samples collected using low frequency GPR and Echer Sounder for the same, almost the same cross sections. Every technology has own restrictions. For ground penetrating radars, low frequency ground penetrating radars, there are few restrictions. First of all, water should have low conductivity. Low conductivity means really low conductivity. For example, here in Latvia, in most rivers and lakes, we cannot use low frequency GPR for bathymetry. Next, low frequency GPR mounted on the drone will have quite deep dead zone below water surface because of bouncing signal between water surface, because water is almost excellent reflector for electromagnetic waves, and large portion of energy of every radar impulse will bounce between water surface and drone body, and that bouncing signal ringing will hide useful data for approximately half of meter of the water under the surface. And next data processing is much more complex compared with the Echer Sounder. But in many cases it works as well. I can share with you, not right now, but tomorrow or after tomorrow, examples of the GPR and Echer Sounder data collected in the same for the same cross sections. Next question from Christian. If I'm not mistaken, the max water depth can reach up to 50-60 meters. Is there any validation work had been done with the common traditional measurements? No, all maximum depth depends on the Echer Sounder model. It can be up to 200 meters, but maximum real depth, what I saw in data from our customers, was around 50 meters, and they didn't do any validations in that surveys. System was validated in the more shallow waters only, unfortunately. But again, we use the same technology. Just a platform for Echer Sounder is different. Next question from Jared. What is the standard distance between flight lines? Standard recommendation for the line separation is approximately 3 meters, 3 times of the expected average depth. Say, if you expect that in your lake or your river average depth will be 5 meters, standard separation is 15 meters. But it is a kind of standard recommendation. Usually, you will need to agree with your customer on the data density. So, and the second part is a comment with that for that question was that 0.7, 0.8 meters per second is quite slow speed on survey lines. Yes, that's the current limitation of the technology, of the system, but we are working on that problem. And but when you will calculate the costs and compare with the manned or unmanned boats, if it is possible to use alternative methods, for example, water is good, you have physical access to the water, you have unmanned boat, you can deliver and you can deploy it. You need to compare all the costs, not just work or minutes required to collect data. In many cases, you will find that bathymetric surveys using drones are very reasonable. Sorry, guys, I'm fully exhausted. Maybe answered rest of the questions in offline. Thank you, guys. Thank you. So I prefer to finish for today.